All right, guys. So we're going to solve these using the quadratic formula. Why? Why would we ever need the quadratic formula? Why can't I just factor? Sometimes you can't factor. So quadratic formula always works, right? So let's go over what the quadratic formula is. X equals opposite b plus or minus square root b squared minus 4ab all over 2a. Good. Because you have to know we're not going to use quadratic formula in quiz or test. I'm not going to give it to you. By the way, we're going to have a quiz on Friday. No, Thursday. You plan on going to college, right? They don't have to, but also there's a college prep course, so I'm teaching the people that want to go to college, take it out. And who knows, maybe if you don't go to college next 2 years, maybe like 20 years down the line, you're like, you know what, I really want to go get a degree. And then you're going to think back and you're hum that quadratic formula song, you're like, thank goodness, I learned that. Alright, so we're going to use the quadratic formula to solve this. There's the squared term, there's the single x term, and there's the constant. We have to use the coefficients for a, b, and c. So I'm just going to write above it. Like a is going to be the number in front of tangent squared. That's 1. B is 4. C is 2. We're using those. I don't usually write the A, B, C. I'm just writing them for the notes. And then we're not going to do x equals. Because I'm not, like if I were factoring this wouldn't factor to, it wouldn't factor to like x plus something and x plus something. It would be tangent x. So I'm actually having tangent x equals. Oops, that was opposite. Opposite b plus or minus square root b squared minus 4ac. Oops, sorry, ac is supposed to be filled in. All over 2 times a. Now I'm going to use my magical powers and I'm going to simplify this really super fast, but I'm not really going over all the steps of simplifying because that is a previous course. And if you need help, you can come see me in XH tomorrow and I can go over how to simplify radicals with you one-on-one. So I simplify everything and I get that the tangent x equals -2 -2 plus or minus radical 2. Okay, that was just me simplifying really fast. Now what I have to do is I have to solve for x. So I have tangent x equals x. But to solve for x, I have to know where, what angle, tangent is equal to -2 plus or minus radical 2. Is that one of the ones we have memorized? No. So we don't have it memorized. The only way we can find it is using our calculator. So to find it on our calculator, how do you get rid of tangent? Inverse tangent. But can you put in plus minus on your calculator? No. So what we have to do is we have to do 2 separate steps. So I'm going to stay organized, and I'm going to do inverse tangent twice, but I'm not going to actually do them both at the same time. I'm going to do inverse tangent of -2 plus radical 2, do everything for that first, then I'll go back later and fill in the other side. But I like to set it up right away so I don't forget to do anything. Question? So, what mode should my calculator be in? How do I know it should be in radian? I couldn't hear you, I'm sorry. Chris, what did you say? Well, we're finding the angle, so there's no degree symbol because I haven't found the angle yet. In the directions, it says 0 to 2 pi. That tells me radian. Okay. So I have it in radian mode. I'm going to do inverse tangent, -2 plus radical 2. And I get -0.5299. So I'm going to put that on a graph. Let's see, this is 3.14. I'm going -0.5299, so down here is -1.57. -0.5299 is about there in the fourth quadrant. My answer, though, is not going to be -0.5299 because the directions say answers are 0 to 2 pi. So I can't have a negative radian. We've done this before. You instead have to add on 2 pi, so you go like all the way around the other side. So my calculator, I'm just going to add 2 pi. And I get 5.7533.
How did you do that?
How did I know to add 2 pi? Because I want something that's coterminal with this, but goes all the way to the other side, so I'm going to add all the way around. One cycle is 2 pi. And then I look at my answer and I say 5.7, that sounds about right for where I'm located. If I got an answer like 7.4, that should tell you you're wrong because that would be more than 2 pi. I have some people on their tests give me answers that are bigger than 2 pi. And next class you'll get this back. Okay, there are 2 answers from 0 to 2 pi. This is one of them. Where tangent's in the fourth quadrant, where else would tangent be at that point? What other quadrant? Second. So I'm going to have another answer over in the second quadrant. You have to know tangent is always either 1 and 3 or it's 2 and 4, depending on if we're doing a negative or positive. So I need to find that reference angle, but in the second quadrant. So if I take pi and I subtract off 0.5299, I will get that second answer. $2.6117. Do you remember doing this before? It's going to be on your exam in 2 weeks. Now that was only half of it. We still have inverse tangent of -2 minus radical 2. So now I'm going to do the calculator again. I'm going to make it minus radical 2 this time. And I get -1.2859. That puts me in the fourth quadrant. Can my answer be -1 point something or another? Has to be between 0 and 2 pi, so I'm going to add on 2 pi so it goes all the way to the other side. 4.9973. And then I say, well, if it's in the fourth quadrant, then tangent is also going to be the same in the second quadrant. So it's pretty much exactly what I did there. And I have to take pi and subtract off the reference angle. 1.8557. Always thinking, if that makes sense for the quadrant, that I put it in 1.8557. That's less than 3.14. It's bigger than 1.57, which is the top. So that makes sense. And then all I have to do is write your answers in fancy brackets, numerical order. Oops. So we can pretty much solve for any equation now that we know we can use quadratic formula. If we can't factor it, we can always use quadratic formula. So if you're ready to go on, look at the next one. I'm just waiting for everybody to catch up. You'll need some space for the next one.
I like to use them.
I was just waiting.
Everywhere. Organized, not weird. It looks like it's real.
So before we start, you already know we can do quadratic formula, but you might not have known that if it was just all mixed together. If you wanted to try factoring first, what would you have to do to the equation? Has to stay equal 0. So regardless, if you're factoring into quadratic formula, it has to stay equal 0. So we'll go ahead and make that say equal 0. So I added cosecant squared x, I subtracted 6. And then we have quadratic form. We're going to use our quadratic formula to solve it, but I'm going to have cosecant x equals opposite b plus or minus square root b squared minus 4ac all over 2a. And then by the magical powers of I already figured the answers out, I will simplify that super fast for you. -1 plus or minus square root of 73 all over 6. It doesn't simplify. So we'll just leave it as is. Now we have to inverse it. But I can't type inverse cosecant into my calculator. So what do I have to use instead? Well, I'm going to change both sides into the reciprocals. Both sides I'm going to reciprocate. Because if I reciprocate cosecant, I get sine. And on the other side, I reciprocate it. It's a fraction. Just reciprocate it. It's okay that there's a radical in the denominator because my directions aren't to find this and simplify it. My directions are to, like, inverse sine that. So I can just type that in my calculator. It's okay. The world will not blow up, I promise.
Will it let you?
Yeah. So, when we rationalize the denominator, that's not because it's, like, not going to let you do it. It's just because that's not simplified. You know, directions are simplified. It's not simplified to leave a radical in the denominator. Just like it's not simplified to leave a negative in the denominator. Nothing's going to happen if you leave it there. It's just not simplified. So we are going to do 2 steps. I'm going to sine inverse 6 divided by -1 plus radical 73. And everybody's going to do this on their own calculator because how you type in fractions in your calculator might be different than the person next to you. So everybody needs to try this to make sure that you know how to type it in correctly on your personal calculator. I will put up 2 different ways you could type it up. You decide which way works for you. If you have the newer models, you can do alpha y equals and get the fraction.
So it's giving me an error.
What did you type in? If you don't have the newer, I'll come look. If you don't have the newer calculators, you use an extra set of parentheses, which I'm doing that up here. So whatever calculator you have, I've typed it in both ways for you. Please try it on yours. Alpha y equals. And then enter. Did you figure out your situation?
Yeah, I think it is. The first time when you came.
Because you didn't put the parentheses, the extra parentheses in. See, I have the extra parentheses. That's why. Yeah, if you don't put the extra parentheses in, you have to tell the calculator that -1 plus square root 73 is all in the denominator. It only thought -1 was the denominator. Who cares? Okay, so once I got that, I'm going to go ahead and draw the picture. Let's see, this is 0.9196. That is in the first quadrant. This is sine. So if sine's in the first quadrant, what other quadrant would sine be in? Second. So the first one is 0.9196 because that one is in the first quadrant. The second one has a reference angle of 0.9196, so we have to take pi, subtract the reference angle. And get 2.2220. Then I'm going to do the process a second time, but with the 6 over -1 minus radical 73. And that gives me -0.6798. I'm going to graph that. That goes in the fourth quadrant. But that means I'm going to have to add on 2 pi to make it go all the way around and become positive. So now I have 5.6033. And then if sine is in the fourth quadrant, it's also in what quadrant? Third. So I'll have to take pi and then add on the reference angle of 0.6798. $3.8214. Then just put all 4 answers in numerical order in fancy brackets. When you have that, turn the page so I know you're going. So everything we just did, we have done one way or another. Let's put it all together in one question. How fun. If I'm going too fast, I will put notes and the video up on Canvas. Let's not have a paper copy in here. Okay. So the last part of the notes today says let's graph y equals cosine x. I'm going to do it in notes. I'm not going to take the time to do it by hand. This will be on your exam. Graphing. Remember how we do graph? We like make a table. And then if there was a 2 right here, do you see there's a 2 right there on yours? What would you have to do? You'd have to do half of what? Yeah, you'd have to put in the x column, do half the x column. So what I have here is cosine bx. B is just a variable. And right now I have my b set to equal 1. So when you look at the graph of cosine x from 0 to 2 pi, how many x-intercepts are there? 2. The first one is at pi over 2, and the second one is at 3 pi over 2. Then what I'm going to do is I'm going to take my slider, and I'm going to make it say 2. So it looks like the second example on your paper where it says cosine 2x. And what we care about, what we're solving for right now, are the x-intercepts. So when you watch it happen, when you watch me slide this, and you watch what happens to the graph. So we have a horizontal shrink. Now from 0 to 2 pi, how many x-intercepts do we have? We have 4. How many full cycles of cosine do we have? We have 2 full cycles. Is there a way I could have known there were 2 full cycles before doing that? No? Okay. Let's make b equal to 3. Now how many full cycles are there from 0 to 2 pi when I make b equals 3? Is there a way we could figure that out before even graphing it? No? Somebody want to explain it to Avery?
No, I just.
Oh, okay. So here's something else we want to look at. So the x-intercepts for, and you should probably write these down under what are the x-intercepts for y equals cosine x on your paper. You write those down. The x-intercepts for just the regular cosine x are at pi over 2 and at 3 pi over 2. But when I put that horizontal shrink, when I make b equal 2, here's my x-intercepts now. There's 4 of them. And now we're at pi over 4, 3 pi over 4, and then there's 2 more, 5 pi over 4 and 7 pi over 4. What happened to the denominator? What? It got bigger, so we said? It did. By like what multiplier? 2. It's like we multiplied it by a half, which is what you do in the table when you graph these. What if I made it 3? 3 is not on your thing, but if I made it 3, we now have 6 x-intercepts. This first one is now pi over 6, where originally it was pi over 2 to start with. See, I multiplied the denominator by 3. Okay, what if we go the other way? Instead of b equals 1, now it's going to be cosine of a half x, which is a horizontal stretch. Horizontal stretch. So now I have how many x-intercepts between 0 and 2 pi? 1. And what's the denominator? Originally it was pi over 2. Now it's just pi over 1. So it stretched out. It like multiplied pi over 2 by 2. Not the denominator. The whole thing. So we're doing that today. But algebraically, not graphically. So the first thing is cosine x equals a half. That's just what we've done in here for a few weeks now. Just where's cosine x equal half? Where's cosine x equal half? Pi over 3. And this is positive. Cosine's positive. The first and the lowest quadrant. What's the second one? 5 pi over 3. That's just regular what we've been doing. Right underneath it, I've now changed it. So underneath it, we have cosine 3x equals a half. So the first question you want to think about is how many full cycles of cosine are going to be between 0 and 2 pi if I put a 3 here? 3. There's going to be 3 cycles. So what we're going to do is we're going to find the x-intercepts for 3 full cycles. Then we're going to shrink it in so they're like between 0 and 2 pi. So we're going to first find just the x-intercepts, the wide ones for 3 full cycles. Then we're going to take it and we're going to shrink it in so they all fit between 0 and 2 pi. So we're going to do 2 steps. So what I think about first is just think where cosine x equals a half. Tell me where cosine x is a half. Oh, we just did that one. At pi over 3 and at 5 pi over 3. So I'm just ignoring that 3 for a moment. That would be the first cycle. Now I have a second cycle. So the second period, the second cycle, you have to add on how much? 2 pi. which if I'm going to add 2 pi to pi over 3, I'm really adding 6 pi over 3. So I'm going to have 7 pi over 3, and then I'm going to add 6 pi over 3 onto 5 pi over 3, so 11 pi over 3. So that would be my second cycle. And then my third cycle, I'm going to add another 2 pi, which is 6 pi over 3. And I get 6 total x-intercepts. But those are not the final answer. Because like 17 pi over 3 is way past 2 pi. So what I need to do now is I need to shrink these in so they fit between 0 and 2 pi. So I have to take all of these, I have to divide them all by 3, or if I have to multiply them all by 1/3. What we would do in the table normally to all the x's, when we have a 3 here, remember how we multiply them by 1/3? Now you're going to do that to all the x-intercepts. And you can think about it as multiply by 1/3, or you can think about it as divide by 3. So I'm going to get pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9.
The top never changes because it's always
Because it's 1/3. Well, I shouldn't say it never changes, but we're not doing any that are just that crazy. We're going to play 6 pi. So again, what we did is we took 3 full cycles, all the x-intercepts for 3 full cycles, and then we applied that shrink.
we simplify them into
And reduce them if need be. Always reduce, yep. Okay, 2 more. So I have sine 2x minus 1 equals 0. I'm going to rewrite that as sine 2x equals 1. And then I'm going to think about it of just sine x equals 1. I'm going to think where sine x equals 1. Oh, I also need to know how many cycles I'm going to have. I'm going to have 2 cycles. So my first cycle, I'm using sine x equals 1. Where is sine x? Sine is y. Where is sine x equal 1? Pi over 2. So my second cycle, I'm going to add 2 pi. But I can't add 2 pi to a fraction, so I have to add 4 pi over 2. And I get 5 pi over 2. So that's 2 full cycles. Is 5 pi over 2 bigger than 2 pi? It is, so I now have to shrink it down by multiplying by half or dividing by 2. Multiply. However you want to think about it, it's what you would normally do in the table if you were graphing this. So we get pi over 4 and 5 pi over 4 as our 2 solutions. Is there a place that I just don't feel that comfortable, not that confident yet? Is there a place I can check my answers? Desmos. I was doing this last night. I was doing these notes, and I didn't have my computer open, so I just do it on my cell phone on Desmos. It works so easily on your phone. It's super easy. It does not take that long to type it in. All right, the last one is cotangent squared 3x equals 3. So how many cycles? 3 cycles. No, there will be 3 cycles. The square is going to give us like the amount of x-intercepts, but this number right here just tells me how many cycles. So for the first cycle, I'm going to think of just cotangent squared x equals 3. I'm going to ignore the horizontal shrink for a moment. I'm just going to solve for cotangent squared x. I'm just ignoring it for a moment. It'll come back. And how do you solve cotangent squared x equals 3? You have to square root, and we square root plus minus. So then where is cotangent x equal to plus minus radical 3? Pi over 6. 7 pi over 6. I skipped one, sorry. 5 pi over 6. then 7 pi over 6. And then 11 pi over 6. So that would be the normal for x-intercepts. The second cycle, I have to add on 2 pi, which is the same as adding 12 pi over 6. We get 13 pi over 6. 17 pi over 6. 19 pi over 6. 23 pi over 6. Now we have our third cycle, where we have to add another 12 pi over 6. 25 pi over 6. 29 pi over 6. 31 pi over 6. 35 pi over 6. So that's just 3 full cycles. Now I have to shrink it up so it fits between 0 and 2 pi. What am I going to do to all of those? Multiply by a third or divide by 3. So our final answer, we're going to have 12 of them, and they're just going to be all over 18. So pi over 18, 5 pi over 18, 7 pi over 18, 11 pi over 18, and I'm just copying all these down and putting them over 18.
Write that in a way that we don't mess right up.
Nah. I'm not going to have that many things to do. Like when we take a test on this, you'll probably have like 2 max that you can answer about this time. Now you could figure it out what the denominator needs to be before you write the first 12 of them. You can combine steps if you like. But I wasn't about to skip any steps the first time you see it. So I've handed out a worksheet. On the front of the worksheet are the multi-angle ones that we just did. And then on the back, there's 2 quadratic formulas. And then at the very bottom, 7, 8, 9, those are just review from the past few assignments. So I'm asking you to just kind of figure out what you need to do on those. And you might get stuck and you might have questions. You have to try something and come see me if you need help. Okay?
So these are the ones that we just did.
The first 4, 1 through 6 are the ones we just did. Those were the ones on the front are the ones we just did. And then quadratic formula says use quadratic formula.